Hello and good day, Geometry here with you to go over math packet number 9, due March 25th, a couple weeks out. Hopefully this will get started on the questions here. So the first one, Jerry had an average score of 85 on his first 8 quizzes. After his 9th quiz, his average score dropped to 81. Oh boy. What score did he earn on his 9th quiz? Okay, so we're dealing with averages here, which would be the mean. So as we know, an average is the sum of all of the data divided by how many data there are. So if the average score is 85 on his first 8 quizzes, that means that he's taking 8 quizzes, and the sum of all of them divided by 8 equals 85. So one method here is to figure out, well, okay, what is the sum of all of his 8 quizzes here? And so multiplying 85 by 8 gives us 680. It's impossible for us to tell which each individual score of the quizzes are, but we know that all of them together total 680 because 680 divided by 8 equals the average score of 85. After his 9th quiz, however, his average score dropped to 81. So his first 8 quizzes plus his 9th one caused his average score to drop to 81. There are now 9 quizzes, so our denominator is 9, and the average is 81. And that is the equation that you're going to be solving here. 680 plus what score on that 9th quiz caused his average to 4 points down to 81. The next one, Brianna and her sister each have a savings account and they each owe money to a credit card company. Who doesn't, right? Brianna owes $1,660 while her sister owes $2,136. Let's call her sister Molly, just because I don't want to use S as a variable here because mine looks so much like my 5. So Brianna and Molly. So Brianna owes $1,660 while Molly owes $2,136. Brianna says, if you give me just 15% of your savings, I can combine it with my savings and pay off my debt. Molly replies, if you give me just 10% of your savings, I can combine it with my savings and pay off my debt. How much money is in each savings account? Oh boy. Okay. So you might not recognize it, but how many variables are we solving for here? 2. And if we're solving for 2 variables, because we have Brianna's savings account and Molly's savings account, if we're solving for 2 variables, how many equations do we need? 2. Sounds like ox and oi to me. Okay, so let's focus on Brianna's situation first. Okay, Brianna owes $1,660. That's going to be our first total. And Brianna says, if you give me 15% of your savings, I can combine with my savings and pay off my debt. So let's have B equal Brianna's savings. And let's have M equal Molly's savings, her sister's. Okay, so Brianna says, you give me 15% of your savings, I can combine it with my savings and pay off my debt. So the tricky part here is that 15%, right? 15% of Molly's savings. Well, if we represent Molly's savings, and there's kind of one similar to this in the algebra packet too, if we represent Molly's savings as M, how do we calculate 15% of that? If we convert 15% to a decimal, 15% of Molly's savings, or 0.15 times M, plus Brianna's savings, the whole thing, is going to equal 1660. Molly comes back and says, well, if you give me just 10% of your savings, I can combine it with my savings and pay off my debt. So Molly is saying she's going to put all of her savings in there, and 10% of Brianna's savings, which 10% is a decimal, is 0.1 or 0.10. And that's going to be enough to pay off her debt of $2,136. So here's your. The question is, how much is in each savings account? You can use substitution for this. This is set up for ox and oi, whichever method you want to use here, but that's how it's going to be set up for you. Next one, 5-card challenge. No need to spend any time on that. You know how these work by now. Just make sure you're getting all 21 points, including a 5-card combination. This one, the printing did not so much come through as what that shaded region is. Let me go back to the original. Yeah, the shaded section here are these 2 triangles on the side. Okay, so you're finding the area of those 2 triangles here of this trapezoid. So first time dealing with a trapezoid, I think, in a while, at least in geometry. The area of the entire figure, the area of a trapezoid is 1/2 times the sum of the bases times the height. Remember, the height is that vertical line connecting the bases. And the vertical line that you need is this one right here. How can we get that? Well, it's a good thing that in geometry we just learned about the Pythagorean theorem, is it not? Because we have the length of a leg, we have the length of the hypotenuse. We can use that information to find the length of the other leg, which also happens to be the height of the trapezoid. I will give you a little bit of help. 80 is the midpoint of this bottom side here, and 14, this is the midpoint of that top side, so the other part of that base is also 14. And that should be enough information to get you going on this one. Pythagorean theorem is going to need to be used here to find the height of that trapezoid, and then how can you figure out the areas of those triangles? Oh, the area of a triangle, that might be helpful too. If you don't know, is 1/2 times the base times the height. Okay. Next one, pattern block question. We talked about this in algebra. Your extra job, in addition to completing the table, is writing those expressions that if I ask you for how many green blocks are in the 21st figure, instead of drawing this table all the way out to figure number 21, you should be able to plug 21 into your expression and give me the answer. So you're looking for, how do I get from the figure number to the number of green blocks in the figure? How do I get from the figure number to the number of purple blocks in the figure? How do I get from the figure number to the number of total blocks in the figure? And since we're dealing with squares, you can bet that your expressions will involve exponents somewhere along the line. Next up, we talked about this one in algebra as well. Your question takes a little bit of a different twist. It says the surface area of the figure is 286 square feet. So in algebra, I gave you the volume. Now I'm giving you the surface area. You still need to solve for that missing side. So let's kind of take a look at this here. We drew our net out in algebra. I'm going to draw it again here. Here's our bottom of the box with side lengths 9 and x. Here's the side with side lengths 9 and 5. Here's the top of the box with side lengths x and 9. And the left side of the box, you can put it on either end of our figure here, but that's going to be 5 and 9 as well. And then the top of the box, or sorry, the back of the box, connect that to one of our bases, either the top or the bottom. That's going to be x and 5. And the front of the box will be x and 5 as well. And as we know here, the surface area is the sum of all of the areas of each face. So I've got my 6 faces here. I'm starting with just kind of going from left to right here. 9 times 5 is 45. That's the area of that first face. First face, I should say. Then going to the bottom of my box, 9 and x. Whatever x is, 9 times that will be the area of my bottom face. Continually going across, I get to the right side of my box, which is also 45, 9 times 5. And then the top of my box, again, 9 and x. Now I go to the front and the back of the box. Each is the same. The area of them, whatever x is going to be 5 times that. And what do I know? I know the total surface area is going to be 286. So whatever x is, when I plug it into that expression, I'm going to get 286. Because that expression, 45 plus 9x plus 45 plus 9x plus 5x plus 5x equals 286. That's how I define the surface area. I know the surface area. That's the expression that equals that. So you could either guess and check, plug in values for x so you get 86, or I would combine like terms and solve for x. And then you can use that value for x once you find it to get the area of the figure, which of course the area of the figure is base times width the volume of the figure. Oh boy, this is my third packet video I've recorded today, so please bear with me. The volume is base times width times height. Moving on to the Magnificent Seven, the 7 solids that we've talked about so far this year in packets 1 through 7. The idea behind this is the same thing that you did in packet number 8. I give you the volume of the figure. You need to write the formula and then give me potential side lengths that would give me that volume. So for example, rectangular prism, the volume is 60. The formula, base times width times height. What would 3 numbers be that could represent the base, the width, and the height that would multiply to be 60? You would write this in. As geometry students, you need to complete 5 of the 7, which means you do need to do one, at least one in the bottom row. And since we're using pi for each of these 3, you will just get an approximate value. That volume is approximately 63. We talked about this in algebra. 60 is not approximately 63. You need to pretty much be 1 above or 1 below. So your range of error there is 62, 64. Then we get to math exploration, which is looking at the binomial theorem with Pascal's triangle. This comes at a great time because we just learned how to multiply binomials together using Old Man Foyle, crab claw, and actually what we're going to talk about in tomorrow's class, the box method. That's CO46. And we're going to use the box method for this just because it's really organized, especially when we don't have any numbers. All we really have are variables here. And a reminder that x plus y squared is equal to x plus y times x plus y, right? It's the exponent is on the outside of parentheses. What we're squaring is everything inside of the parentheses, which is x plus y. It's that times itself. So what the box method has us do is, since we've got a binomial times a binomial, we're making a 2x2 box, right? One binomial goes across the top, x and y. The other binomial goes down the side, x and positive y. And each square, we're going to fill in this box by putting the product of the terms that it connects. So like this first one, top left corner here, is x times x, which is x squared. The top right corner is x times y, which is xy. The bottom left corner is y times x, which we're going to write xy, standard form. And then the bottom right corner is y times y, which is y squared. And when we write this out in standard form, notice that I can combine my like terms here. I have 2 terms of xy, meaning I have 2 xy's plus my x squared plus my y squared. And that same expression is written over here with all of the coefficients and exponents written in. So even though it's not written when we write it, 1x squared, x to the first, y to the first, and 1y squared. And what we're noticing here, 3 things. First of all, the exponent on our original expression was a 2, right? xy squared. It's got that 2 there. Therefore, our coefficients, 1, 2, and 1, is the second row of Pascal's triangle. Remember that top row is actually row 0. So row 0, row 1, row 2. Okay? The powers for x decrease in each term. Our first term has an x squared, 2. Our second term has an x to the first, 1. And our third term, our y squared, doesn't have an x term, so it's like it's x to the 0. And the powers for y increase in each term. X squared doesn't have a y, so it's like it's y to the 0, and then y to the first, and y to the second. Oh boy. Okay, that's a lot of algebra. That's a lot of variables. That's a lot of powers. How does it help us? Why do we care? If I ask you to multiply x plus y cubed, which if you were to write that out in expanded form, would be x plus y times x plus y times x plus y, you need to do the box method twice. You need to do the box method to multiply these two binomials first, and then take that product and use the box method again to multiply that by another x plus y. It's a lot of work. And it looks like I need to show the steps below for that. That's lame. Why did I say that? Ugh. Okay, well, we already know that x plus y times x plus y, these first two is equal to x squared plus 2xy plus y squared. So in essence, what we have here is we have x squared plus 2xy plus y squared times x plus y. So using the box method, what type of box do I need here? I need a 3 by 2, right? I've got a 3-termed expression times a 2-termed expression. I need a 3 by 2. And again, like I've said in class, or like I will say in the class if we haven't actually done this yet, make your box longer than you think it might need to be, because we've got, exponents, we've got coefficients being added in here. You don't want to try and cram these products into a small space. So we're going to divide this into 3 sections. Divide this into 2 sections. I'm going to put my binomial, my 2-term expression down the side, and my trinomial x squared, 2xy, and y squared across the top. Now, you might be asking yourself, well, wait a minute, isn't that not in standard form? Because shouldn't our y squared come before the y? Technically in standard form, yes, you would be correct there, okay? Actually, no, never mind. Scratch that. I wish I knew how to edit these so I didn't sound like an idiot. Because each of these have 2 powers, the x and the y still is a sum of 2 powers. Then you go alphabetical order by variables. Never mind. Scratch that. I didn't say anything about that. Okay, so going to multiply this, our top left box here, x times x squared is an x cubed. The next one over, x times 2xy is a 2. X times x gives us x squared. And then we have the y. The last box here, x times y squared is x y squared. Bottom row, x squared times y is x squared y. Y times 2xy is 2xy squared. And y times y squared is y cubed. And I have that expression with all the coefficients and powers written in over here. And again, notice what's going on here. The exponent on our original expression was 3, all the way back here, x plus y cubed. Therefore, the coefficients are going to be what's in row 3 of Pascal's triangle. 1, 3, 3, 1. 1, 3, 3, 1. The powers for x decrease each term. 3, 2, 1, and no x term is like an x to the 0. And the powers for y increase in each term. Y to the 0, 1, 2, 3. For comparison, if I asked you to cube x minus y, the only thing that changes is that the negative sign alternates. Your x cubed is positive, then negative, then positive, then negative. Same thing up here, x minus y squared, positive, then negative, then positive. Okay, why do we care? Well, when you probably get to more algebra 2, you'll be asked to expand things like x plus y to the fourth. Okay, thanks. How do I do that? Well, since our beginning exponent is a 4, I know my coefficients are going to be the numbers in row 4 of Pascal's triangle. 1, 4, 6, 4, and 1. I know my x powers are going to decrease in each term. So starting with x to the fourth, x cubed, x squared, x, then x to the 0. It's like it's not even there. My y powers are going to increase from term to term. So 0 in the first term, and then y to the first, y to the second, y cubed, and y to the fourth. And since I'm adding all of these together, since my sign here is positive, plus, 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 I'm done. I can go home early. To expand y, x minus y to the fourth, it's going to be the same thing, only it's going to alternate positive and negative signs. My first sign in my first term is going to be positive, just like it is positive x to the fourth, but then minus 4x cubed y plus 6x squared y squared minus 4xy cubed plus 1y to the fourth. And so for x plus y to the fifth, you'll be looking in the fifth row here. I know I didn't leave you a ton of room to write. I think you're going to write smaller than I do, hopefully. It'll fit here. But multiplying binomials, again, Pascal's triangle. Think about it. It's such a simple pattern. But yet, look at how it applies to a complex concept of multiplying binomials. Math, it's also connected in ways that you might never think of. But there you go. Mean, median, and mode. Again, with the grocery store, same idea as in algebra. You're buying the same sort of stuff. So the mean, median, and mode answer that you got for algebra is the same mean, median, mode as for geometry. But because you buy these items on a family trip to Arkansas, groceries are taxed at 1.5%. After adding tax, what is the total cost of your food? So in algebra, you decreased the total by 8% because you got a discount. In geometry, you're going to increase the total by 1.5% because it is an additional tax. And then, hey you, with what's supposed to be a smiley face or something like that, a smile. Where do all these polynomials fit together in this figure? Have fun with this one. The clues of the figure should be very helpful here. So that is math packet number 9. It is due March 25th. I encourage you to turn it in early so that I can check it over, steer you in the right direction should you need steering. But enjoy. Have a great day. See you soon. That's how you math. Don't forget to like and subscribe.